So let's start with the hypothesis testing questions. And first question is, let's say there is a company called ABC, which is a manufacturing company or making products, and they basically manufacture chocolate packets. So every day they manufacture like thousands of chocolate packets, and they believe and claim that weight of each chocolate packet is 300 grams. So the question is, how to check or test or validate whether their belief and claim is correct or not, whether they are really making or manufacturing a packet which has a weight of 300 grams. Now let's assume the scenario, if ABC is manufacturing only, let's say 1000 packets or 500 packets or 1000 packets, then we can check it manually each packet and see whether the weight of each packet is 300 grams or not. But think in that way that if a company is manufacturing like hundreds and thousands of packets every day or every month, then it's not very easy to check each and every packet. So what we will do in that case is to use a concept of central limit theorem and inference statistics. So for this, we will going to use a hypothesis testing to see whether ABC claim is correct or not. So what we are doing here is that instead of checking each and every hundred and thousands of packets, what we will do, we will pick randomly 50 packets from the population or a sample of 50 packets. And those random selected 50 packets, let's say each have certain weight, like let's say first weight is 270.5, second has 282.32, third has 308, 299, 302, 291, 286 and so on. So let's say these are the weights of selected 50 packets. And we found that the mean weight is 294.6 grams. Now through hypothesis testing, we want to understand whether the selected sample are statistically significant or not. So there are a lot of information on this slide, so let's go one by one. So let's assume that we have selected 50 packets and these are their selected weights, 278, 282, 308 and so on. So what we are doing is that X bar is equal to 294.6. So the mean of the selected 50 packets are 294.6. And the hypothesis mean, which we believe and claim, it's equal to 300 grams. So that is 300. And the standard deviation of those selected 50 packets, these are the selected 50 packets, their standard deviation is coming to be 10.98. And number of packets what we have randomly selected, n equal to 50. So the steps which we are planning to take to check the statistical significant or not, these are the 4 steps we will take. First, we will define and state what is our null hypothesis and alternate hypothesis. Then we will specify what would be the significance level. The third, we will calculate the p-value from t-value for the sample data. And then finally, based on the p-value, we will compare with the significant level whether to reject or not reject our null hypothesis. Now since the claim of the company that each packet they believe equal to 300 grams, so since there is a sign of equal to, that equal to I am putting in the null hypothesis. So mu is equal to 300. So that would be our null hypothesis, mu equal to 300, because we believe that the weight of each packet is 300 grams. And obviously the alternate hypothesis will be mu not equal to 300, not equal to 300. So now we have defined our alternate and the null hypothesis. So the next step is we will define the significant level. So the significant level we are taking is equal to 0.05. So 0.05. Now the next step is we will calculate the t-value. So the formula for t-value is x bar minus hypothesis mean divided by standard deviation and under root of n. So after putting the values 294.6 minus 300, we are getting the t-value which is minus 3.47. So on the right side of the graph, if you see, I have plotted this distribution, and 300 is our claimed hypothesis mean, and we can see that on the graph minus 3.47 is going towards the tail end of this graph, which looks like that when we calculate its p-value. So this p-value I have calculated in the Excel sheet. So there is a formula like t dot this if you put the t value, which is minus 3.47, then comma, then number of samples -1. So we have selected 50 samples, so 50 minus 1, 49, and then degree of freedom equal, I'm taking as 1, so comma 1. So the p value I'm getting 0.004. Since this is a two-tail test, so I'm multiplying by 2 and I'm getting the value equal to 0.01. Now we have calculated the p value for this test, which is coming to be 0.01. Now we will compare with the significant level. As we defined our significant level equal to 0.05, so we can see that p value is less than significant level, which is 0.0.1. So it means we will reject the null hypothesis. So since we are rejecting the null hypothesis, so it means that alternate hypothesis is correct. So we can conclude that let's assume there could be a multiple scenarios. The conclusion would be, if we feel that if H0 or our null hypothesis is true, if we feel that is true, and then for some reason we find a wrong 50 samples, then what we can do is to try this complete test again with a different 50 samples and see maybe in those 50 samples our null hypothesis will be, we will accept the null hypothesis. Otherwise, if this test is absolutely correct, it means that ABC manufacturing company has to stop their manufacturing and correct the weight of the packets, because it means that whatever they believe and claim, that is not correct. The weight of the packet is not 300 grams. They have to stop the manufacturing and correct the weight of the packets, because our p value is less than the significant level. So we are rejecting the null hypothesis. It means our mean is not equal to 300. It means it will be alternate hypothesis. And the other scenario, as we discussed, that if a company feel that, hey, the samples what you have taken, that 50 samples, is not a correct representation, then we can try to test with another or 50 samples and see if we can get some different results on that. Now these are the hypothesis testing. The another thing what we can do is to find the confidence interval. So we can take like a 95% confidence interval, and when we put the values in this formula, x mean, x of bar plus minus t into s divided by under root of n, we are getting 291.49 to 297.7. So it means that this saying is that there is a good chance that the population the population what we have for the packets, their weights are somewhere in between 291.49 to 297.7, which is clearly less than their claim of 300 grams. So it means that ABC is not doing correct when they are labeling their weights. So they have to stop the manufacturing and correct the weight of the packets.